Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class we are going to discuss a numerical on the topic center of gravity of symmetrical section. Let's go to the numerical. Find the center of gravity of a channel section 100 mm multiplied with 50 mm multiplied with 15 mm. Okay. Here, this only that question, the diagram is not given. The channel section means we have to draw like this. This 100 mm, that will be the total length, and 50 mm, that will be the total breadth. And the thickness of all three rectangles, that will be the third dimension, 15 mm. Actually, this channel section is symmetry about the horizontal axis. Okay. Normally, to calculate x bar, we will take the leftmost line as the reference. Leftmost line of the given area, that will be the reference axis. To calculate the y bar, we will take the bottommost line as the reference axis. Okay, so here this one is the leftmost line and this one will be the bottommost line. When a plane area like this channel section is symmetry about the horizontal axis, we don't want to calculate the y bar, because here you can see from the reference axis, wherever if you are going to calculate the y bar, that means for an example, here if it is symmetry about the horizontal axis, the center of gravity will be on that neutral or the central axis. Okay. For an example, if the center of gravity is here, from the reference axis, this will be at a distance. Here you can see the total length is 100. So this will be 100 by 2, 50 mm. So this will be at a distance 50 mm. It may be the center of gravity is here, 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 here. So if it is symmetry about the horizontal axis, x axis, then we won't calculate y bar, because the y bar is actually here 50 mm. Actually, guys, then here we have to calculate only x bar. The x bar formula I just write here for our reference. Here actually three areas, that means this given channel section, we can split into three small rectangles. This rectangle 1, this rectangle 2, and this one, the rectangle 3. Okay. So here, when you consider into small three rectangles, we can write a1x1 plus a2x2 plus a3x3 divided by a1 plus a2 plus a3. Here, a1, a2, a3 are areas of the three rectangles. x1, x2, x3, that and all, the distance of like x1, center of gravity of the first rectangle from the reference axis, second rectangle from the reference axis, third rectangle from the reference axis, that is x1, x2, x3. Here, guys, this formula, the x bar formula, y bar formula, that and all, we discussed in a separate video, that is center of gravity by moment method. Okay. So from that, it may be mass or volume or area with respect to the given condition that we discussed elaborately. So that video link is given in the description box of this video. If you want to watch that video, go to the description box of this video. There will be the link. that is center of gravity by moment method. So the derivation of this formula that you can see. Okay, same the formulas of the rectangles, area of the rectangle, and not only the rectangle, all the area or volumes. Okay, that is an overview of center of gravity. So in that video we discussed that elaborately. That video link also given in the description box of this video. So just go to the description box. The two video links will be there. An overview of center of gravity and center of gravity by moment method. Okay, it's better just watch that video. There will be the reference video for this numerical. Okay, so here first I am going to start with the rectangle 1. Okay, first the rectangle 1. In the first rectangle, I am going to calculate area and the distance between the center of gravity of the first rectangle from the reference axis. Here actually this bottommost line, that will be the reference for vertical axis, sorry, y bar, that we will not use. Only this leftmost line, that only here we are going to use. So first one, for the rectangle 1, area, that is A1. This dimension is 50 and this dimension is 15. We know that it will be multiplication of the two dimension, length into breadth or BH, whatever. So 50 multiplied by 15. So 50 multiplied with 15. So we will get 750 mm square. Okay. Then x1. Actually, the distance of center of gravity of the rectangle, that will be, if this is the dimension b by 2. This dimension, if this dimension is d, that will be d by 2. So the center of gravity probably here for this rectangle. So if this is 50 mm, from this point, actually here you can see all the leftmost lines of the rectangles are lie with the reference axis. Okay, this is the reference axis for x bar. Okay, and this one, that is the reference axis for y bar. Okay, so here x1, that will be, if the distance is 50, then that will be 50 by 2, that equal to 25 mm. Okay, same for rectangle 2. Rectangle 2, we are going to calculate the area, that is same way A2. Here guys, from this point to this point, that is 100 mm, and this one 15, this one 15. If you subtract this dimension, okay, that will be 100 minus 15 minus 15. Okay, then we will get this dimension will be 70 mm. That is 100 minus this 15, this 15, we will get 70. So that vertical dimension is 70 and horizontal dimension is 15. So the area of this rectangle will be 70 multiplied with 15. So we will get that equal to 1050 mm square. Okay, then x2, this linear dimension parallel to the x-axis, that is 15 mm. Center of gravity of this rectangle, it will be probably here. So that will be 15 divided by 2. Okay, that will be 15 by 2, that is 7.5 mm. Then the third rectangle, that is rectangle 3. Okay, for rectangle 3, the area, actually this rectangle is symmetry about the first rectangle. So area and x1 we will get same, because this is linear dimension 50 mm, vertical dimension 15 mm, and the leftmost line of the particular rectangle 3 lies with the reference axis for x bar. So it is symmetry about the rectangle 1. So here A3, that is 15, 50 multiplied with 15. So we will get same 750 mm square. Same way, the value x3, that is 50 by 2, we will get 25 mm. Then substitute in this formula x bar. X bar equal a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. Now substitute all the values, whatever we calculated here. So we will get x bar equal a1, that is 750 multiplied with x1, 25, plus a2, 1050 multiplied with x2, that is 7.5, plus a3, again 750 multiplied with the x3, that is 25. Okay. Divided by a1 plus a2 plus a3. a1 750 plus a2 1050 plus a3 again 750. If you simplify, we will get the value of x bar, that equal to 17.8 mm. And if it is symmetry about the horizontal axis, the y bar, that will be from the reference axis half of the distance. So if it is 100 mm, the total length from the reference, this will be the y bar. Okay, that equal to 100 by 2, that means 50 mm. So the y bar value, that is 50 mm from the reference axis. Okay, I hope you all understand this video. To watch more videos on the center of gravity, don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver. Thank you guys. Thanks for watching.